Welcome to Meet the Expert session. In today's session, we will review the new monitor mode in Alteon. My name is Rio Tirosh. I'm a product manager in the ADC PM team. I'm responsible for platforms for the Apple integrated and also for the performance of both. Together with me, Imran Khan, who is our professional service engineer, who will lead the technical part. Let's review the agenda for today. So I cover the solution overview, which include the out-of-path mode, the monitor mode, the traffic flow, the monitor deployment, and also the supported platforms. Imran will lead the technical demo, which include the out-of-path settings, the WAF as a monitor, and the integration with defense messagings. If you have questions, please skip to the end, and we will review it later. Out-of-path. Out-of-path is a mode that we already have in integrated Apple. In the last few months, we invested a lot of effort to realize it and make it more reliable. We keep investing to increase the performance of Apple in general, and I can say that today out-of-path mode is much better than the out-of-path mode we had in 6 months ago. So let's talk about this deployment. We have in Alteon, which is inline. The Alteon gets the traffic to this SP. The SP forward it to servers and also duplicate the traffic and send it via kind of a copy port to the integrated Apple. The Apple is sniffing the traffic and detect if an attack, and of course sends security events. In this mode, Apple cannot mitigate attack, only detect. The new mode, which is called monitor mode, is a bit different than out-of-path. In this mode, Alteon is not part of the inline traffic. We have a router or a switch or even an ADC for it. The switch gets the traffic forwarded to the server and also duplicate and send copy of the traffic to the Alteon. The Alteon in this mode acts as a transparent traffic to the integrated Apple, which is in monitor mode. The Apple can report the attack and send security events. In both cases, Apple cannot mitigate attack. If you would like to mitigate, we can use the defense messaging. One more difference between the modes is the operation mode. Out-of-path works as an inline mode, which means Alteon gets the incoming and outgoing traffic. And in monitor mode, the operation mode is out-of-path. Alteon and Apple is not part of the incoming or outgoing traffic, and it's not impact the traffic. So here we have a table which compare between out-of-path and monitor mode. So regarding operation mode, in out-of-path, Alteon is in inline mode, but Apple is out-of-path. In monitor mode, both modules, Alteon and Apple is path. Let's see an example. This is a deployment of monitor mode. As you can see, traffic get inside the network. The switch for the traffic to a server and also send a copy of it to the Apple, to the Alteon. The Alteon, as I mentioned, doesn't act as a load balancer. It just forward the traffic directly to the Apple. Apple can detect attack and send security event to an analytic system. It could be also a vision. Let's go back to the table. So operation, we just talked about traffic flow. I reviewed with you the first slide. The Alteon role in out-of-path. So Alteon act as a load balancer. and TCP terminator, which means in open session, closed sessions respond to a SYN packets, and also we have the benefits of Alteon in this mode. For the monitor mode, Alteon doesn't act as a load balancer. It doesn't modify the traffic and also doesn't change IPs. It just open and close sessions, and doesn't act as a proxy here. As for the HTTPS in out of base, since we use Alteon as a load balancer, we enjoy the SSL terminator we have in it. As for monitor, currently we don't have SSL support. We should implement it in the next several months, hopefully before February. As for delay in out of path, of course we have delay because Alteon is part of the incoming outcoming traffic. In monitor mode, we don't have delay. Basically, we have zero latency. VX support supported in out of path, but doesn't support it in monitor. So in monitor, we must work with Apple as a standalone mode. I will cover the supported platforms in a moment. Security events we have in both modes, and supported version in out of path, all versions supported. In monitor mode, since we released the monitor mode in August, currently we support 32.6.2 and up. So the supported platforms, currently the supported platforms in monitor mode, here we have the list. So currently 8420 and 9800 doesn't support standalone mode, which means it doesn't support monitor mode. In the future, we might implement standalone mode in both platforms, but currently it doesn't support. So to summarize what we went through so far, basically the question is, why should I use monitor mode? So the main purpose is to detect and report about attacks with zero latency. As I said, we have no traffic mitigation in this mode, but if you like to mitigate the attack, you can use the defense messaging and signaling the attacks to the defense point, the perimeter. Also, this mode is great for POCs. I can say that we have a lot of potential to win deals with this mode, and also it could be as a staging environment or in production environments. So that's it for my part. Imran will take the lead for the technical demo. Thanks, guys.
So thank you, Roy. I will be presenting the technical demo on inline out of path settings, WAF as monitor in defense messaging. Before I go to demo lab, I will show you the lab settings, network settings, what I have in our lab. We have a client, we have defense flow, the traffic is passing to defense flow. I have deployed Alteon in inline mode. The Alteon is deployed in inline mode where we have VIPs 192.168.200.2 and our web server is 200.100. So this is inline deployment we have configured. I will show to go back. This is Alteon. Configure virtual server. Type is 192.168.200.200 with the real server bandit, the backend server 200.100 and bandit the Sequa inline policy over here. And Sequa inline tunnel is out of path. And now I'll try to initiate the traffic from the client machine. And we can see the traffic coming, active connection, the transitions per second, transition rate. That means the app will have visibility to all HTTP request and response. So even though this is the AppFall module is deployed out of path, we can see the traffic is coming to AppFall. So now we will try to generate an attack. Go to forensics, default view. We can see the request coming here. The event is generated security filter, which is reported on the Sequa inline tunnel, the tunnel what we have enabled on the services and bind it to the virtual server. This attack parameters, attack name, and the parameter value, that is script. This is an SQL injection cross-site scripting script. So we can see this events. We have visibility of this events even though the Sequa is deployed in out of path without disturbing the customer's actual environment. Now we will talk about monitoring mode. I'll go back to my slide. This is network topology for our monitor mode. This is a client. Defense Pro. This is a virtual virtual switch here, and our web web server. Now we'll initiate the traffic from client to the to server, direct server. There's 192 at 192.168.200.20. Now LTO is connected on the virtual switch. It is out of path deployment where virtual switch NIC is configured as premises or a mirror path, and all the traffic would be copied to the Alteon and integrated WAF. For example, show in a Sequa tunnel is an out of path with monitor mode enabled. This monitor mode enables helps us to deploy the application traffic the simple way and have analysis and uh, Appfall have a security events visibility uh, without any impacting the application and any risk of the customer or production environment with out of path, and we have the same features, same policy configuration, auto configuration, manual configuration. Same configuration can be done in the auto path in mirror mode. Now this also have an ability to block the malicious source IP with the defense messaging to a defense mode deployed in the perimeter level. Now I'll run to the demo, walk to a demo on this. I'll switch back to my demo lab. So for monitor mode, we have enabled on the port 1. This is a this is the virtual port or physical port of Alteon, which is connected to a switch, and that virtual switch is in the promiscuous mode, in a mirror mode. The span port, all the traffic passing through the switch from the client to the server are being copied to on this interface, and through this interface, Alteon would be capturing on the filters, and on the filters we have applied AppWall security tunnel, that is AppWall monitor, and we get the visibility of all events, and on that basis we will see all events, and we can detect all events, and we can report these events, and we can do signaling to a defense pro on the perimeter level, and to block all the source at the perimeter level before entering to the applications. This is port setting. We need to check if the port is up or down, and in the port processing, I'll go to the port processing. The default value for the port processing are normally client and the server. We have disabled this, and we have enabled this monitor and filter outbound. Now I'll go to the filters. This is the filter what I have configured for. I want to showcase this new tab which is available in the new version. What we have introduced, this is the monitor tab, which was not available in the earlier version. With the help of this monitor tab, we're going to monitor, we're going to capture all the traffic which is coming on that interface, and on that interface we'll setting to the AppWall module, and from that AppWall module we can detect all events, and from that we can send the block events to our Defense Pro device. So this is the filter what I've configured: VLANs, TCP, application, HTTP, the source and destination source. You can have a specific source, you can have a specific category of source, network class. It's same similarly different destination. Here I've mentioned my real server, the backend server. You can mention the network class or specific destination IP with the specific port, and this filter is bind on the interface one, which is the mirror interface. Here I'm not connecting to a VIP. This is all directly connected to a real server. That means we are not sitting in LAN, we are sitting outside, only the mirror traffic is coming here. And on HTTP, I have enabled a SecVamon tunnel, which is configured. The SecVamon tunnel as similar properties what we have for inline gateway. Same way we have configured. For that, I will try to generate. I'll go this. Go to dashboard and reset all the connections and see if the traffic is coming here. I initiate the traffic. I will directly hitting to my real server, that is 200.20. I'm hitting it multiple times and see the events. We can see this connection is coming. We can see the transaction rate. That means that the AppWall is having visibility, complete visibility of the packet of the payload, that is HTTP request and response. Now we can do the filters. We can report to this. So even though this is deployed in out of path, only the mirror traffic, we have complete visibility of the security events. I'll try to recreate a similar attack. Changing the VIP to changing to my real server. I go to forensics. I deleted the earlier logs. You can see the logs from particular source IP address, hitting the same database filter. This is the cross-casting error attack generated. Response header 304. And our tunnel. The tunnel is a SecVamon tunnel, which we binded to the filter. I'll try to generate one more attack. You see this SQL injection code generated right now with the same tunnel, the same source IP address. The attack 2, this parameter is attack 2, where we are trying to inject the SQL query in the parameter. Inside this is SQL query. So we have this visibility over there. Now how we do signaling, how we can block this, all requests, multiple user requests, how we will block, we'll see. I've configured source blocking. Okay, source blocking, we have here 3 level of blocking level 52 and a half is 69, level 2 70 to 89, level 3 90, level 1 whenever there is a penalty score, any source IP which is reaching the penalty score from 50 to 69, that particular source would be blocked for 5 minutes. Level 2, when the penalty score reaches 70 to 89, that user would be blocked for 15 minutes. Similarly, level 3, beyond 90, it will block for 100 minutes. I will enable this source blocking right now. Submit. Go to the penalty. See this, all vulnerabilities, all events have a penalty score by default. 1, 2, 5, database for file uploads. Now this is one event, one brute force event, one allow list event have a security level of 5. For example, now multiple one source or multiple source are trying to attack this. One source is that has generated 5 brute force attacks, or 5 file upload, or 5 2 parameters. So for 5 into 5 is called 50. So that particular source come into category of 50, and for that particular source would be blocked for 15 minutes. This events keep on blocking. This is the block source. Right now we don't have this here. I've configured signaling. It is going to my Defense Pro. Sorry, I'll try to generate an attack. So that we can see this is the CDN attack with the multiple source IP address. You can see this is generated. Yeah, see this event. This is all passive. We have deployed in all passive mode. This is the IP blocking, Defense Pro attack source should be signal block the Defense Pro based on the source IP address. This is the DP IP address, and this is the source, the signal to be blocked. I go to configuration, source blocking. Now we can see this has been blocked and signal to a Defense Pro. I'll go to Defense Pro. This policy has been auto-generated, sent by our AppWall. It's a drop action, and all box source will be there. The source what we have seen there, it is come automatically over there with the help of the Defense Flow signaling, and we are dropping it. The policy is generated drop, and dropping it at the perimeter level. The same source IP address over there. Which you see here. So Defense Flow is blocking at the perimeter level with the help of the defense messaging, and AppWall is sending the traffic which is out of path. What we have in the lab, and the documentations are available on the site. I will put it in the chat on defense messaging, and question and answers. You can send your questions to our community and raise all the queries. We would like to answer over there. We have the community there, and all the links are there. Thank you for your patience and valuable time.